All right. Shh. What we're gonna do is we're gonna continue to talk about sequence. So let me give you a sequence. See if you can figure out what will be the formula for it. That's and then we're gonna see are they converge or diverge in a second. So let me try to give you one. Rules. Okay. Uh-huh.
There's a bunch of stuff blocking
Those bunch what? Oh, sorry. Let me see. Quick time.
What?
Yesterday we did one already, so no. I need to get out first. And log it back in. All right. The one I'm gonna give it to you is a little bit tricky, so you gotta think about it a bit more. Okay. So if I have a sequence, it's -1, 1/2, -1/6, 1/24, and -1/20. We require some type of notation we haven't used for a while. Don't say anything. See if you can figure out. You need a parenthesis on a -1.
What do you mean? Oh, you're right.
A bit knows, right?
Remember how you do an iterative process? It's a previous one. Yeah.
A bit should be BC.
It might be C.
Bro, it's the denominator. You're multiplying by one at a time. It's on the
Yeah.
one more. It's a unit.
I mean, I know the pattern, but I don't know how to. Oh, is it?
It's a different new note. It's a notation we have talked about before, but I haven't done it for a while. Huh?
Oh, no. The allegations, and he's not.
All right. How many of you guys got it? Raise your hand. Raise your hand. You got it. 2, 3. I have a bit got it. He's not even BC. Come on.
I got it.
All right. Good job. All right. It's a factorial. So it's actually an is represented by general form as -1 to the n over n factorial. Do you guys know factorial? Well, first of all, you need to know 0 factorial is equal to what? No, it's 1. 1 factorial is equal to 1. 2 factorial is equal to 2 times 1. 3 factorial equal to 3 times 2 times 1. 4 factorial equal to 4 times 3 times 2 times 1.
Okay. For this, would you need to make sure? Ew. Do the n equals 1, and then would you have to put a 5 up top?
Huh?
Because it's only the first. Because it's only 5 terms, would you put a 5 up top or no?
Yeah. You need to. But what I meant to say is I forgot to write down dot dot dot, but that's fine. So that would give you the certain thing. So this is a new notation.
History, right?
Yes.
Why is the factorial of 0, 1? Big math.
You told me what? You come up with the reason. I know the reason. I know the reason.
Because 0 times 0 is 1, obviously.
You come up with the reason.
Is it like an exponent type of thing? Like I know
I'm getting outside.
It's like an exponent, yes.
I like that.
So in order from here to here, right?
Yeah.
You divide it by 4. You divide it by 3, right? You divide it by 2. And you divide it by 1.
That's smart.
So factorial is something that you need to know in terms of this. All right, so there's also something in Algebra 2 that we don't teach anymore. It's called recursive sequence. How many of you guys have heard recursive sequence before?
Yes, I remember that. Oh, wait, no.
Who's your algebra teacher?
Miss Carvalho in 7th grade.
7th grade from where?
Wendy Ridge.
Oh, okay.
It was like one of the first things we learned.
That's pretty cool.
Wow.
X minus 1.
So here, the notation can say is A1 is equal to 2. A2, this is an example. This is not a notation, but a notation of a recursive is going to be a to the n plus 1 is equal to 2a to the n minus a to the n minus 1. So obviously you already have first term, right? First term is a1 is equal to 2, a2 is equal to 4. Now, if you want to get a third term, so it's a to the 2 plus 1, right? So if this is 2, so it'll be 2a to the 2. Is that okay? Minus 2 minus 1 is a to the 1. Yeah.
It's basically the same as having f of x.
2 times
At
4
x minus 1,
minus 2 is equal to 6. Can you tell me what the third term and fourth term is?
where you have to have.
Now this is, it's called recursive. Now, does a recursive always set up this way? No, it could have 3 times a to the n minus a to the n minus 1. There's always some term there is a current term and a previous term, and your next term is given by the recursive formula.
So you have to have an initial function.
Yeah, so this is called recursive. Yeah.
Is that second thing that you have boxed, is that a formula or is that the equation given to us?
The equation, this is example.
Okay.
I can give you any type of example recursive, but this is how the recursive formula is going to work, and you can tell the next few series. Can you tell me what's a to the third? A to the 3 is equal to, sorry, a to the 4th, sorry. A to the 4 is equal to what?
3 plus 1.
3 plus 1, and then that's equal to 2. A to the what? 3 minus a to the 2, right?
Yeah.
So what is 2 times a to the 3? We already got from previous one, 6.
12 minus 4, which is 8. So, this one's kind of weird because it just ends up being 2a. Or 2n.
Yeah. But it's a funny way to write a recursive. So no, this is the type of sequence that we learn in algebra 2. A lot of you guys don't have the problem of math these days. They just kind of every year they got rid of something. So when I was taking algebra 2, we had to learn about matrices, and they're no longer teach matrices. And when I was in algebra 2, I had to learn about conic section. They get rid of algebra 2, and conic section used to be on pre-calc, and they got rid of in pre-calc.
Maybe it's good that they got rid of it.
No, it's actually very, very helpful, especially if you are going to engineering. But now the kids have no idea how matrices work, including myself, because I don't teach it anymore. So I don't remember. Yeah, I taught it the first year, and then after that, I was like, oh, I don't need to teach it anymore. It's out of curriculum. They got rid of law of sine, law of cosine in pre-calc. They got rid of a lot of things in the pre-calc. They got rid of a lot of things in algebra 2. So now kids coming to calculus have no ability, and this is a problem. All right, so is any questions here?
We prefer constants or quadratic spaces?
It's work with I guess you can work with anything, but any questions here? Okay, so let's talk about so this is recursive. Now you can have if you can do a limit, and if you limit approach something, if it converge into a number, then the sequences converge. If limit does not exist, then it's diverge. So you can say limits as n approach to infinite on the sequence of a to the n. If the limit exists, then sequence is converge.
So it's basically the same as an improper.
Kind of, yes. That's why we need an improper integral. That's why I give you a huge test about improper integral, because you want to think about everything in terms of infinity now, as a rather than just to a boundary. If
Infinity isn't rooted.
if not, the sequence is diverge. Divergent. Okay, so first of all, there was some property you have to understand, and those are property very, very intuitive. A lot of people like to say, "Oh, this is very, very common sense," but make sure you know them. Limit as n approach to infinity of c to the a to the n is equal to c limit of n approach infinity of a to the n. Yeah, the constant can take it outside. So just like derivative or integration, the same thing. Second one is limit n approach to infinity of a to the n plus b to the n is equal to limits as n approach infinity on a to the n plus limit n approach infinity of b to the n. Now this looks kind of like distribution property, but it kind of makes sense. If you limit approach one thing, adding to limit approach another thing, you can break it up.
Does this only apply when n is going to infinity, or could it be when n is going to anything?
It will apply to infinity, will apply to anything.
But most likely you'll use it on infinity.
Yeah, because we want to see if they are converge or diverge. Okay, same thing. They have a rule for multiplication as well. Limit n approach infinity of a to the n times b to the n as equal to limits of n approach infinity of a to the n times limits of n approach infinity of b to the n. So those are very, very standard property. Some of you guys probably think that's, I don't even need to write that down because it's intuitive. But nonetheless, I still have to tell you because this is the first time we deal with a sequence. Obviously, you can write that as limit approaching infinity a to the n over limit n approaching infinity of b to the n. Same thing as 5, which is limit n approaching infinity of a to the n to the p. That you can say is equal to a parenthesis of limits n approach to infinity of a to the n to the p. Like I said, any of those are very, very easy. Is very easy to understand.
Basically, it's just saying you can make it up.
Yep. Now I want to show you the example of converge and diverge. So convergent or divergent. So first one, what do you think this one? -1 to the n. Is this converge or diverge? Think it, let the other people think it first, Ethan. You're gonna be one of the fastest one in here as far as deal with this kind of stuff. Because you in a bit is probably one of the few people can think CAPVC the fastest. But if you spill the answer, then other people stop thinking. Okay, let me call on some of you guys. Kaiwan, what do you think? Does it converge or diverge? You're not even here. Your mind's not here. It's a convergent or divergent. It's a multiple choice. And most you get it wrong. You picked the wrong one. Because it does not go into a certain number. So it's not going to a certain number. You got -1, you got +1, you got -1, you got +1. So it's going to be undecided.
Oh, it is going to be.
Yeah, so it's divergent. You cannot go confined into a value, right? 2. The next one is gonna be a little bit different. How about a to the n equal to 2n over n plus 1? Do you think this converge or diverge? And why? Two-way to approach it. Two-way to approach it. Don't worry, I will ask you a hard question. I pick the thing. I pick the question that you would think. You have to think a bit more. Tana, what do you think? Why?
Because the top's gonna be increasing faster than the bottom, so it's not gonna be like
Okay, so Jing, what do you think? Why do you think it's converge? A bit.
horizontal asymptote. Yes,
Melissa? I never call him Melissa, but I really want to call him Melissa more because I need to hear her speak. Converge? So it turns out a lot of definition, a lot of idea is correct. So horizontal asymptote is probably the easiest thing to look at. Is they will converge into a value. The reason being is two ways. You can choose to be it L'Hopital rule, right? So then it's going to be 2 over 1, so that's equal to 2, right? You can also be it divided by highest degree. You have to know both because sometimes you will see that it's going to be 2n over n over n plus 1 over n when limits n approach infinity. And that's the horizontal asymptote way, so which is 2 over 1 plus 1 over n. This reach infinity, this is just eventually 2. So two way to approach it. Two way to approach it. Does that make sense? Okay, how about this one? This one's gonna be interesting. So a1, an is equal to 2 plus negative 1 to the n over n. I'm not gonna ask you this, Ethan, so I'm gonna ask you the next one. So okay, I'm gonna ask Corbin Lewis.
Yeah. Corbin. Not too sure, but I'm leaning towards diverge.
Okay, that's fair. Raphael? Diverge, okay. Elise? Wesley? Kashif? Diverge, okay. Nathan? You got converge, okay. Jordan?
If n is getting bigger, if you're just manipulating if it's plus one, if it gets like the sequence is gonna get so small.
Yeah, like 3 over infinity versus 1 over.
Okay, so let me extend that question a little bit further. Jordan, is there any way I can prove my math? Like you think about it's called numerical approach. A numerical approach, you think about all this number, let's keep on going higher and what will happen, which is great. But can you give me an algebraic approach to do that?
You can split the fraction and then do limit, bring out the n power, and then do a partial mean.
Did you graphically?
Well, if
Could you get an answer like graphically? Like if I said since negative 1 to the n is basically like increasing to 1, it's like a wave translating into 2. But then since I'm dividing by n, the wave gets smaller every time, so it converges to 0 or wherever it goes.
okay. So does everybody convinced going one way or another, or are you still undecided?
I mean, I'm pretty sure it's converging at 0, right?
I don't know. I'm asking you. I'm asking you guys to think because you gotta think on your own term. The reason why this part, and I'm gonna be honest with you, like the idea, I'm not very good at calculus too. So by you guys give me feedback of different things, it give me like different ideas as well. I know I'm doing, don't worry. But this is my 3rd or 4th year teaching. I need about 6 years to get master at what I'm doing, or to get as good as well as be able to do it Calc 1. So this still, like, even Luke Davis is my first guinea pig actually. But yeah, so what you can do is algebraically you can divide it by n, top and bottom. What happens if you divide it by n? N approach infinity 2 over n plus negative 1 to the n over n over n over n, right? This part is going to be 1, and this is 0. This still 0. It doesn't matter oscillating or not, because the bottom goes larger, it doesn't really matter, right? If you approach negative 0.001 or 0.001, your approach is still going to 0 regardless. So it's still going to equal to 0. So this one converge, right? So their question a little bit more difficult. How about an to the equal to natural log of n over n? This is converge or diverge. You can think it numerically, and you can think about how do you approach algebraically, right? Ln over n.
It's just zero. Yeah, imagine it a hop.
El Hospital rule is actually a good choice. Because it's not possible for me to compare it to ln of n. I cannot divide top and bottom by ln of n. You're gonna figure out that it end up to be the same thing and over and over and over again. You're gonna keep on ln over n, right? So obviously divided by highest degree does not work in this case because you're gonna keep on getting repeating cycles. So then you say, oh, El Hospital rule. So let's say limits and approach infinity of ln of n over n. That's equal to 1 over n, right? 1 over n over 1. So if we approach infinity, that's still going to go to 0. So it's converged.
Now be back from A1.
Now this one's a tough one. Is this one converge or diverge? Jing, what do you think? Huh? Converge, okay. Raphael, what do you think? Converge. Sophia? Kashif? What do you think? Aiden? Rajesh? Elise?
Infinite t minus infinity. Like, if that's indeterminate.
Yeah, I think.
But then I was also thinking like the n plus 1, that wouldn't make that much of a difference.
Nathan?
No, it's 0. I got an E. I got conjugate. You lost. Look at this one.
You got ln both sides. Like,
So the answer is converge. But algebraically, kind of different. If you have two radicals, what can you do?
Multiply by the conjugate.
Multiply by the conjugate. Because that's essentially the same, right? And if you do that, what will happen? N plus 1 minus n over square root of n plus 1 minus square root n. Oh, sorry, this is a plus. So that's gonna give you that's gonna give you 1 over n plus 1 minus square root n. When limits n approach infinity, but this is a plus. Sorry. This is a plus. So this one is gonna give you 1 over infinity, so eventually goes 0. So multiple paths you can think. The problem calculus 2 is kind of hard is because you have plan A, plan B, plan C. You can use all of them to get a right answer. But in this case, there are a few tools that you can do. You can do El Hospital rule. You can do conjugate, and you can do divided by highest degree. So there are multiple routes to take care of situations. And well, this one obviously divided by highest degree doesn't work because it's not a fractions, right? So there are certain things that is better to work on certain thing, and it's not better to work on the other thing. Okay, let me give you one that's a little bit more interesting. Is this converge or diverge?
Is it to you? Wait,
Yeah, you can't outline
not
it.
all of
I mean, this one increases fast. Often increases fast. It doesn't work. Oh, wait.
Okay. Let me ask Kaiwan, what do you think?
I thought it was 2 and then.
Laxmi, what do you think?
I haven't finished my calculation. I'll say converge.
You say converge, but which route did you take?
Well, I'm still doing my algebra, so I'm not sure yet.
Okay. How about Maya? Maya here? Raya here? Oh, okay. Yeah. So Landon, what do you think?
I'm trying to work on it. I'm trying to do a thing with afterlog, but it's not really working out.
Okay, so if I take a derivative, remind you guys how to take a derivative of this. So limits n approaching infinity of n squared over 2n minus 1. So that's d to the dn here. Or I should write it in terms of x, but too lazy to do that. So that's going to be 2x, obviously. And on the bottom is going to be derivative of ln, a derivative of 2 a to the x is equal to ln of a to the x. Do you guys know why? Because y equal to a to the x, ln of y equal to x ln a, y prime over y equal to ln a, y prime equal to ln a y, so a to the x. So that's going to be ln 2 times 2 to the x. If it goes to infinity, you can take a derivative again. So that's going to be 2 over ln 2 squared times 2 to the x. So if limit x approach infinity, I'm going to use x. So that's equal to 1 over infinity, or 2 over infinity, which is 0. So therefore it's converge.
How did you get that denominator?
It's the same way as like when you derive e to the x. The only reason the derivative of e to the x is because technically it's ln e, which is 1. So that's like the wrong way.
No. I mean the second time. How do you get ln of 2 squared times
You can keep doing it again. You divide it.
Oh, because it's a constant.
So is this a converge, right? Is that okay? Let's talk about a squeeze theorem. Yeah, squeeze theorem is a big old squeeze theorem. So the definition of squeeze theorem is going to be pretty easy. It's a to the n less than b to the n less than c to the n. If you have one thing less than the other and c to the n is the biggest, if both limit as n approach infinity of a to the n is equal to limit n approach infinity of c to the n, that's equal to L. So if the both side is greater to constant, the result is then limit n approach infinity of b to the n has to equal to L. If you can create the thing, usually is very useful for sine, cosine, right? Those are very useful situations, but this is a little bit different.
Because there, so for like sine of x, there wouldn't be any
Yeah.
right?
Except for I think like
Sine of-
There is no sine of infinity.
Well, I think the last time we deal with squeeze theorem is like a sine of 1 over x, something like that. Yeah. Okay, anyway, so what we're gonna look at this specific series is am equal to n factorial over n to the n. Ooh, the new one, n to the n. So which one's larger? Which one's gonna go faster? N to the n or n factorial?
Because I thought it was factorial and I was wrong.
Good. I like what you guys are thinking.
yeah, it's fine. It's gotta be exponential.
Big. No, how do you take the derivative of x?
Yeah.
And L and N.
Yeah.
No, for factorials. How do you get factorial? I guess that's what we learned.
Oh yeah.
I mean, in that case,
Yeah, there's no effect and smaller. Yeah. It's a lot of words, but I'm saying.
How do you take the derivative of a factorial?
See, that's a problem, right?
Okay, great, Jordan. Now, how about you think of a solution?
She's like, just think. Duh. You can do this. So this one's a kind of like you have to kind of think about both way. So that's why the Calc 2 is very hard to like perfect at teaching, because there's a few different thought process you should go through. Now let's just assume something. Let's say a1 is equal to 1 factorial is equal to 1 factorial over 1 to the 1. And that's equal to 1. Yes, that was easy. And this one is equal to 2 times 1 over 2 to the 2. Would you say? And that's equal to 1. I mean, but we had to establish another thing. It's less than or less equal to 2, just ignore this term because 1 is not important, right? So 2 times 2. So they are either equal to or less than. So we're going to talk about that. We're going to increase the third term here. It's going to be, third term is going to be 3 times 2 times 1, which is, this is the time that you got to see. 3 times 3 times 3. Would it be less than 3 times 3 over 3 times 3 times 3? Would it be less than?
Wait, why do you have 3 times 3?
I'm choosing to represent this in terms of n to the some type of power, rather than n factorial.
Why?
Times 1.
Why would you choose that?
Yeah, but how did you get that?
We're gonna create a situation where it can make sense for us. So we know that this for sure is gonna be larger, right? Larger than this, right? So instead of you thinking about factorial, we take that to comparison to the n to the n
minus
power.
1.
Yes, n to the n minus 1.
And we know it's less than that, so it means the bottom is more.
Yes, Rajesh is actually really good. Okay, so 4 times 2. No, I'm gonna show you. Keep on showing you this. 4 times 2. So 4. That's 4 times 3 times 4, and we're gonna times 4 times 4 times 4 times 4. We know that this is the actual series, but we know that 4 times 4 times 4, and here 4 times 4 times 4 times 4. It's going to be less than that because 4 times 4 is bigger than 3 times 2. But if I do one more, I'll just do one more, just kind of show you. A to the 5, so it'll be 5 times 4 times 3 times 2 times 1 over 5 times 5 times 5 times 5 times 5. It's less than 5 times 5 times 5 times 5 over 5 to the 5th power. Because this for sure greater than this, right? Now we already create a bound. Now obviously, as that's gonna be rewritten as n to the n minus 1 over n.
So how did you find that that's good?
Because I want to compare to, in terms of something that I can compare. Rajesh kind of is one step ahead because he knows that this simplified down to 1 over n. And if you limit n approaching infinity, 1 over n is always going to go 0. But this is less than that. If it's less than that, so this has to go to 0 as well because of squeeze theorem.
So whenever it's a factorial, do n to the n minus 1?
Well, you compare with the n to the n plus 1 because that's the easiest comparison that we can come up with.
Okay.
Because it's really hard to come up abstract comparison, and you have to understand that there's comparison what happened here. Because this is gonna be this is gonna be for sure greater than all the time.
Yeah.
All the time it's always gonna be greater than.
But even
So then we can rewrite this into a, we can change that to n to the n plus 1 over n is less than n factorial over n to the n.
I have not been
What?
writing that. I need to like
N to the n.
start writing it.
So this going down here, that's going down here, and we say, oh, okay, well,
So you can put 0 for the right term and say it's less than or equal to 0.
yes.
That's cool.
It can't be less than because we're not possible.
So what happened is just have to result with this. Well, what happened? Limits as n approach infinity.
Because because you're using
Because n to the
Okay.
n minus 1 is less than n.
because you're wanting to make something that's greater than, so that you can use squeeze theorem because you already have 0.
Thank you.
What? No, I'm so.
I'm like-
I'm so.
I'm vaguely getting it.
Insanely lost.
You make it something bigger, but you take that bigger value, you reach the infinity.
Okay.
And that's still going to 0, therefore the small one has to go to 0 as well.
Yeah.
Because the one we have is the small one. but we are compared to this because this can be simplified down to a very easy simplification, so you can reach that.
So that's approaching in zero?
Reach infinity. So it's that's how squeeze theorem work. You had to come up with something that's bigger.
It made sense.